So hi, today we are going to discuss this question, partition list. Wait a second. Yeah, okay, we are going to solve this question named partition list. Okay, so the question says we are given the head of a linked list and a value x. So we have to partition it such a way that we have to partition the list such a way that all the values of the nodes, okay, that means all the nodes having value less than x should come before x, and the values greater than equal to x will come after the node x. Okay, and we should preserve the original relative order of the nodes in each of the two partition. That means if two this two is occurring before this two, then this two here, this one is this two, and this one is this two. Okay, or for example 4 is before 5, so here also 4 will come before 5. Okay, now, and so we have 1 4 3 1 4 3. Here also see 4 is coming before 3. Now, how do we actually solve this? For solving this, the question itself this says partition. The question says partition. So we need to partition the list. We need to separate the list in two things. Like we can have a left partition and a right partition. Okay, so we'll have left partition and right partition. Now, okay, partition. Now everything in our left means every value, every node whose value is strictly less than x. Okay, and in right partition every node will come, every node which has a value greater than or equal to x. Okay, so in the left, let's take this example. In the left of 3, in the left of 3, what will come? 1 1. Okay, 1 will come, and we have 2, then we have another 2. Okay, this 2 and this 2, so this will come before this one. Okay, so this one is this 2, and then we'll have another 2, then we have another 2. Okay, this one is our left, sorry, left. Now for right we have 4, then 3, then 3. After 3 we have 5. After 3 we have 5. Now this one is our right partition. Okay, or yeah, and for this one, check for this one also, where we written this one 2 1. The x is equal to 2, so the left will be 1 and the right will be 2, because 2 is equal to 2. Okay, and 1 is strictly less than x. Now 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 how will we actually do this? For doing this we require a left part. Okay, or say a left head and a right head. Okay, left head and a right head. Okay, now in the left head, let's say a pointer, left ptr will point to our left head. Okay, right now left head is containing nothing. Okay, left head is containing nothing, and right pointer is just pointing to left head. Right pointer is just pointing to left head. Now we see here 1 is less than 3. Okay, so we'll put 1 here. That means right left pointer dot next will be our 1. Okay, now we will check which is 4 greater than, sorry, is less than 3. No, it is greater than 3. So we will point another right pointer and point its next to 4. Okay, all the elements greater than equal to 3 will be pointed by the right pointer. Okay, now this was our head. Now head goes here. So we saw that 4 is greater than 3, we put 4 here. and now right pointer is here pointing to 4. Okay, right pointer is pointing to 4. Now 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 head points to 3. Now we check, is 3 less than, sorry, greater than equal to 3? Yeah, 3 is equal to 3, so we'll point right to 3. Again we see 2. 2 is less than 3, we'll point the left to 2. Now we check 5. Check is greater than 3, so here comes 5, and we have 2, so which is again less than 3, so we'll have this one. At last see, 2 is pointing to 2 is pointing to null, and 5 is pointing to 2. 5 is pointing to, let's say, 5 is pointing to 2. Okay, okay, let's say this connection is connected with 2, this 2 here. Okay, I cannot draw here, but just assume, or just imagine that this link is between these two. Okay, now that means this is a part of left part. Okay, left partition, this one. But we at last we need to connect the left pointer and right pointer to form a whole new linked list like this one. Okay, so what do we need to do? We'll point this two pointer dot next to the right head dot next, that is equals to 4. So it will point to right head dot next. Okay, and this 2 will point to, this 2 will change, sorry, this 5 will point to null, will change their pointer. So now 2 is now, this 2 is now connected with 4, and 5 is our last node because it points to null. Okay, so that is the main logic. We need to separate it in two partitions, left partition and right partition, and the last node will point of the left partition, last node will point to the head of the, or say head next of the head of the right partition, and the last of the right partition will point to null. Okay, so just we need to code that. For coding, okay, so we need a right head, so we'll have right head is new list node, and we need a left head, list node left head equals to new list node. Now 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 we need a pointer which is pointing to the right head and a pointer which is pointing to left head, so we need two pointers. List node, let's say left ptr equals to pointing to right, sorry, left head, left head, left head, and list node right ptr is pointing to our right head. Now now we will traverse till the last of the list, that means until the value of this node is not null. Okay, that means we have to traverse from head, or say we can have one more pointer, uh, list node temp equals to head until temp goes null. Okay, now while temp is not null, we will traverse. What we need to check, we need to check if the current value is less than x. Okay, we'll check if temp dot val is less than x. If it is less than x, if it is less than x, that means it is our in our left subtree, or say left partition. So left pointer will point to this temporary node, so left ptr dot next equals to temp. Okay, and we need to traverse left also, because after this left will come here, means we have traverse one, this one is left, now left will go here. Okay, so we'll have left ptr equals to left ptr dot next. Now if it is not true, that means, if it is not true, that means temp's value is greater than or equal to x, that means it is in our right subtree. For that, same thing, just we will put right here. Okay, here we will put right. So right ptr dot next is our temp. Okay, and and right ptr dot this one, right ptr equals to right ptr dot next. At last, see, we are traversing temp, no, so temp should also traverse. We are traversing this list node, so temp will traverse. So at last temp equals to temp dot next. Now 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 we need, see, this was our left subtree, this was our left sub partition, and this was our right partition. Now we need to join them. Now 2 was pointing to null, but we need to point to the head of the right partition. So what we'll do, 2 is in our left, the last node of our left is left ptr. Okay, because left ptr itself is traversing itself. So left ptr dot next is our the the right head. Okay, but right head has no current value, so right head dot next, because we are in pointing to the next. Okay, left pointer dot next, left pointer is pointing to head, head is pointing to none, and left pointer dot next we have the current value or the temp value. So equals to say right head dot next, and the last of the right pointer, see, it is pointing to this node, so the right pointer will have to point to right pointer dot next will point to null. Okay, at last we need to return the new head, that is the left partition's head. So we'll return left, sorry, left head dot next. This one is our the left partition's new head, or the new head of the whole tree. Okay, so this all thing should be done here outside the while loop. Okay, now let's submit. Let's run first. Yeah, yeah, see, good time. And yeah, what is the time complexity? Time complexity is big O of n. Why big O of n? Because we are traversing just in a single while loop, no more multiple or nested while loops are there. Okay, just one while loop. And space complexity, see, we are creating 4 nodes. Okay, 4 list nodes. So, and inside the while loop, are we creating any nodes? No, we are pointing to the next, but we are not creating any new node. Okay, we are not creating any new node. So we have a number of nodes created. We have 4, and what is 4? 4 is a constant. So time, sorry, one more node, that is 5. Node temp. That means we have 5 nodes. So space complexity big O of 5, or let's say big O of 4. Okay, because we will see that we don't require this temp also, we can traverse with just head. Okay, so that is big O of 1. So space complexity is big O 1, and time complexity big O of n. Linear time, constant time. Now one thing that we can do it with using our head also. Head, and we can say head, this one will be our head. Head. Okay, now here also head equals to head dot next. Now this one will also run. Okay, because too many pointers will confuse us, so just traverse the head. Yeah, see, it will run, and just submit. So see, we are using 100%, we beating 100% of Java users. So that is the main concept. We need to partition the list in left partition and right partition and join them at the last. So that was all. Hope you like it. Thanks.